All right, what do we do if we have a polynomial that we want to factor, where we see no common monomial factors? Let's consider for a moment the polynomial xy plus xz plus ay plus az. Looking at this polynomial, I see that the pairs of terms, these two and these two, they have something in common, right? These two terms have a common factor of x, and these two terms have a common factor of a. Addition is associative, so I can think about just these two pairs of terms. Why would I want to do that? Well, at minimum, I can now factor out a common factor from this pair, namely x. What's left of the first term? That'll be y. And what's left of the second term? That'll be z. And over here I can factor out a common factor, namely a. What's left of the first term? Well, that'll be y. What's left of the second term? That'll be z, won't it? Hey, this is kind of big. If I think of this y plus z binomial as just a block, what does that give me? Right? I have x times my block plus a times my block. I can think of this block as a common factor. So this is just my block times, well, what's left of the first term is x. What's left of the second term is a. I think I've just factored this as a product of two binomials. I think that this is y plus z times x plus a. Does that work? If I multiply this out, right, I'll get y times x plus y times a plus z times x plus z times a. And these terms look different than these do, and they're in different orders. But y times x, that's the same as x times y. Y times a, that's the same as a times y. Z times x, that's the same as x times z. Z times a, that's the same as a times z. So what have we done? We started with a polynomial with four terms. First, we split the terms into two groups based on something they have in common. Then, what did we do? We factored out the greatest common factor of each pair. And then, what was our last move? We noticed that the two remaining binomials were the same, and we treated that as a common factor. Now, there's another way we could look at this, though. One that doesn't rely on making this move. We can think of this in terms of binomial multiplication. Let's suppose we want to write this polynomial, x cubed plus 7x squared plus 2x plus 14. Let's say we wanted to write this as a product of two binomials. Well, the thing that we realize is if a product of two binomials has four terms in it, we never combined like terms. Why? Because there are only four pairs of terms from two binomials. That means that when we multiplied our two binomials, one of these four terms was in each box. So I'm going to group twice. I'm going to group the rows based on something these have in common. It looks like these have 7 as a factor and the other 2 do not. So I'm going to make one row 7 a factor and the other row 7 not. It also looks like 2 of these have 2 as a factor and the other 2 do not. So I'm going to make one column 2 a factor and the other column 2 not. What does this look like then? In this box, I want to write the term that has 2 and 7 as factors, so 14. In this box, I want to write the term that has 7 but not 2, so this term. In this box, I'm going to write the term that has 2 but not 7, so this term. And then in this box, I'm going to write the term that has neither 2 nor 7, this term. Now what am I going to do? I'm going to go to each row and find the greatest common factor. It looks like in this row, the greatest common factor is 7. And in this row, the greatest common factor is x. Now, this is the point where it might not work. It might not work. Yeah, we might have chosen the wrong way to group them. Now we hope that the remaining factors in each column agree. So let's see. In this column, what times 7 gives me 14? 2. Does 2 times x give me 2x? Yes, that works. What times 7 gives me 7x squared? Well, it better be x squared. Does x squared times x give me x cubed? Yes, that worked out. We'll see an example of what it looks like when this doesn't work out in a future video. What are my factors then? Well, one factor is written down the side and the other across the top. My original polynomial factors as 7 plus x times 2 plus x squared. I'm going to give you one of these to try. Write x squared y minus y cubed plus 4x squared minus 4y squared as a product of two binomials. Pause the video and try this now. All right. Well, it looks like my obvious way to categorize my terms is x versus no x, 4 versus no 4. So here I'll have the term with a 4 and an x, 4x squared. Here I'll have the term with no 4 and an x, x squared y. Here I'll have the term with a 4 but no x, negative 4y squared. And here I'll have the term with no 4 and no x, negative y cubed. All right. Well, looking at this row, what do I see I have in common? I'll have an x squared in common. Looking at this row, what do I see I have in common? Well, I have a y squared in common. And now looking at this column, what times x squared gives me 4x squared? Well, that's going to be a 4. Does 4 times y squared give me negative 4y squared? No, it doesn't. Oh, but wait. These are both negative, aren't they? So maybe I should say that this is negative y squared. I think that's going to be better. Right, because then in this column, what times x squared gives me x squared y? Well, that's got to be a y. Does y times negative y squared give me negative y cubed? Yes, it does. So notice, sometimes we need a negative common factor. And you'll notice that when it comes along. What are my factors then? Well, I have x squared minus y squared times 4 plus y. Again, reading off the side, reading off the top.